Okay, pre-calc fans, today we're looking at what are called rational inequalities. Okay, so this is what a rational inequality looks like. It's a fraction that has an inequality. Okay, now, so here's the ideas. So we're going to plot these stuff up. We're going to plot all the zeros on the number line, the numerator zeros and the denominator zeros. We're going to do that plus minus scheme again. And then we're going to write solutions. Whatever we do not, this is an absolute must. You do this, you're just going to get the problem wrong. We do not cross multiply. Okay? The reason why we don't cross multiply because we will not know the direction of the inequality. Okay? So here are our rules. First thing we have to do is get the fraction to 0. Whether that's a less than or equal to, greater than or equal to, we got to make it say 0. Okay? Then we're going to combine fractions. So right now, here's number 1, here's number 1. This is already set to 0. So number 2, we would have to combine fractions if we had to combine fractions. That's right, that means we have to have a common denominator. Okay, number 3, we're going to factor the numerator. We have to get the zeros. Okay, we have to factor the denominator. So the factors of x plus 3, well, this is already in factored form, so the 0 here is a negative 3, and the 0 here is a positive 2. Again, just like when we did the polynomial inequalities, write out your roots somewhere so that you can put them in the proper order when you put them on the number line. Okay, now we're going to plot these 2 points on a number line. I'll do my number line right here. Okay. And so negative 3, then 2. Now this is very, very important. When we do the number line, you have to know if you have an open circle or a closed circle. Okay? The numerator, it depends. It's open or closed. It all is based on the inequality. Now, this inequality is a greater than or equal to, so this negative 3 right here is a closed circle. If there was a strictly greater than, in other words, no equal, then it would have been an open circle. So the top depends, okay, based on the inequality. The the denominator is always an open circle because when x is equal to 2, this is 0, that's undefined, okay? So the denominator is always an open circle. So be very, very careful when you're doing that, because that's the difference between a correct answer and losing a point on a test or a quiz. Okay, so we plotted the zeros, so we made our regions, and now we have to do our plus minus schemes. Okay, so I'm going to put my x plus 3 first, and then I'll put my x minus 2. So here's your little regions, just like when we did the polynomials. So to the left of negative 3, that's right, it's positive for x plus 3, and then to the right it's negative. And then here we are, x minus 2. There's 2 right there, so to the left it's negative. Oh, what did I do here? What did I do? My goodness. So this is a minus on the left, plus on the right. All right, here we are. So now we are x minus 2, so to the left it's negative, to the right it's positive. Okay. Now, just like when we did our polynomial work, remember we were doing multiplying the signs? Well, it's the same thing. Remember, when we divide different signs, if the signs are the same, it's negative. If the signs are different, if the signs are the same, it's positive. If the signs are different, it is negative. Okay, so here we're dividing. Okay, when we divide likes, it is positive. When we divide difference, they are negative. No big deal. Okay, so greater than or equal to 0, that's right, we're looking for positive results. So negative divided by a negative is positive. Positive and a positive is positive. You don't even have to say divide. Just look at your negative signs. If it's an even, it's positive. If it's odd, it's negative. Okay, just like we did before. All right. So we know how to state the solution set then. We see where the solutions are using our integral notation. We have negative infinity to negative 3 bracket parentheses, union, or, use the word or, and we have 2 with an open circle to infinity. Remember, that 2 was open because it was a denominator, and that it cannot be equal to 0. There, we followed the rules, we did our work. Nice and easy. Yes, I know you'll have fun adding fractions. So here's number 2. I'm going to try and keep the rules there so we can keep seeing the rules. Okay, number 2. Again, this one's already set equal to 0. Let me just do my number line right over here. Yes, the 0 at the top is a 5. This one's a negative 3. So negative 3 goes first. And then we have 5. That's right, negative 3 is the denominator, so that is always an open circle. And then 5 is based on this inequality, so it's closed. Okay. All right, now I'm just going to start doing my plus-minus scheme. Okay, all right, let's go back through the rules. So we get the fraction to 0. Yeah, it's already to 0. Combine, you didn't have to worry about that. We factored the numerator. So the numerator, the 0 is 5. And that was a closed circle because it was, the inequality is less than or equal. The denominator, factored form, is negative 3 is the 0. Plotted that on the number line. And that's always an open circle because that's when it's undefined. Okay, now we're going to make our, do our plus-minus scheme. So just like what we did with polynomials, I'm going to put my x minus 5 at the top, x plus 3 at the bottom. It does not matter. Remember, all you're doing is counting up the signs or multiplying. Same as for division, the sign issues. All right, here's negative 3 here, x plus 3. To the left, it's negative. To the right, it's positive. And there's x minus 5. There's the 5. Left, it's negative. Right, it's positive. And again, oh, see, now we're looking for less than or equal to 0. So where are we less than or equal to 0? That's right. Negative and a positive makes it negative. And there's your solution. And now be careful. That's an open circle. A negative 3 with a parentheses, comma, 5 with a bracket. There's your solution set. Okay. All right, let's look at question 4. See, now here's question 4. Look at this. We have to get it to 0. So we have to move the 4 the other way to make it get it to 0. So 2x plus 2 over x minus 3 minus 4. Okay. There's our first step of getting it to 0. Now we have to combine fractions. Oh my lord, how do I combine fractions? That's right, we have to have a common denominator. Oh, what is the only denominator? That's right, it's x minus 3. So we have to multiply this, top and bottom, by an x minus 3. Oops, I forgot my less than or equal to 0 here. All right, now, I'll move up here so I have more room. So let's see, I have my one denominator. And then I have 2x plus 2. We didn't have to do anything with that. So now it's a negative 4. It's a negative 4 times each of those. So minus 4x plus 12. Okay? Now I have to combine like terms at the top. So I have negative 2x plus 14 all over my x minus 3, less than or equal to 0. Now I'm going to factor the top. Now notice what happens when I factor the top. I'm going to factor out a negative 2. That negative 2 is a factor, but it's not a root on the number line. That negative 2 will change your answers. Okay, so we need a row for negative 2. For that negative sign right there, it is not a factor. Excuse me, it is not a 0. Okay, it is not a 0. There's only 2 zeros here. That's right, the only 2 zeros are 7 and 3. Okay, negative 2 is a factor that we have to worry about. It is not a 0. But we do have to worry about that factor, though, because it's negative. Remember, when you multiply anything by a negative number, it changes the sign. So let's do our number line. We only have 2 zeros on this number line. The only 2 zeros are 7 and 3. So I'm going to put the 3 first, and then the 7. And what's my inequality? So the denominator 3 is always open, that's right. That 7 is a closed circle. So now the factors we have to put up on the side here. That's what I always do. I put the factors up on the side. Okay, here's my factor of x minus 3. Here's my factor of x minus 7. Then here's my factor of negative 2. Remember, negative 2 is not a root. It's not a 0. But it is a negative number that we have to worry about. All right, let's start with the easy 2 that we already know, then we'll worry about this. Okay? All right, now. All right, here we are, x minus 3. There's the 3 to the left, it's negative, right, it's positive. There's the 7, all right, x minus 7. Left, it's negative, right, it's positive. All right, now, this negative 2 right here, remember what I said, it is not a 0. That's how I have no region to look at for it, or no number on the number line to worry about. But what happens is, it is another factor of this equation, and negative 2 matters. So it's multiplying each of these 2 pieces by a negative number. So we have to put it in there, okay? So in other words, it's saying whatever this answer is, we got to multiply by a negative 2, okay? All right, so that's what we have to worry about, that negative sign. It's not a 0, but it is a negative factor that we have to worry about. Now, if this was a positive factor, we would not care, because what happens when you multiply a positive number times anything? That's right, the signs do not change. When we multiply by a negative number, signs change. So that's one of those little subtleties that we have to worry about. We even had to worry about it with the polynomials, but it didn't happen in any of our polynomials work. Actually, it happened in one of the homework assignments. No, it happened in a notes assignment, in the notes, not in any of the homework. All right, so now we're ready to worry about our when it's negative and when it's positive. We're looking for less than 0. When is this thing negative? Well, 3 negatives is negative. And the negative, one negative, odd number, times positives is negative. That's right, negative and a negative is positive. So this is where we are, we're negatives on the tails here. So we have a solution set of negative infinity to 3, parentheses for both because that's open. Infinities always carry parentheses. Union, 7 on a bracket because it's closed, to infinity. Okay. The other way of handling this negative 2 would have been divide everything by a negative 2. But if you do that, your inequality would flip over, and you're looking for greater thans, zeros. Okay, so you could do that. And if you're looking for greater than zeros, this row would not be here. And now notice your answers are still the ones that are highlighted in orange. Negative times a negative is positive. Positive times a positive is positive. Because then, remember, you divided by a negative, made that inequality flip over. Okay, that's if we divided by a negative. So I just wanted you to see that. So we have our solution set. All right. Number 4. All right, step 1. That's right. We gotta get it to 0. So I gotta move this to the other side. So plus 3. I'm gonna give myself a little space. Greater than 0. Okay. Now we have to combine fractions. That's right. Rule number 2 is to combine fractions. So what's my common denominator? That's right, x plus 2. So I'm going to multiply top and bottom by an x plus 2. And I'll do my work up here. So I have one denominator of x plus 2. And then, so I have x minus 2 over here. And then positive 3 times each of those, so plus 3x plus 6. And then I'll combine the top. So what is that, 4x plus 4 over x plus 2. All right, so we'll factor the top. Oh, there's greater than 0. So I'll factor the top. There. Now, remember, 4 is not a 0. That's not a 0. Okay, so your zeros are only a -1 and a -2. That's it. Those are your only zeros. Let's get those on the number line. Now, I know I'm not stressing about this, and we're going to talk about that. So let me get my factors over here on the side. So here's my x plus 2. Here's my x plus 1. Okay. Remember, the order in which you write your factors down over here doesn't matter. Notice I did not put a spot for 4 because there is no 4 on the number line. Okay? 4 is not a 0. It's a factor. It's not a 0. In fact, it's a positive factor. So does a positive factor change anything when we multiply by positive numbers? No, the signs will remain the same. If I multiply by a positive, the signs remain the same. Okay? So in other words, if I divide everything by 4, do I have to worry about flipping this inequality? No. Remember, you only flip the inequalities when you multiply or divide by a negative. 4 was positive, so we don't even need to worry about the 4. It's not needed. Okay? All right, so what do we have here? Remember, denominator's always open, numerator's based on what we have. Okay, so what are we looking at? We're looking at strictly greater thans here. No equal signs, so both are open circles. All right, here's my regions. All right, remember, I don't need a spot for positive 4. If I put a spot for positive 4, it's all positives. That doesn't change anything. The only thing that changes would be negatives. That's why I had to put a row of negatives. All right, so let's just start filling things in. So left of -2 is negative. To the right, it's positive, 4, x plus 2. And then here we are at x plus 1. There it is. Left is negative, right is positive. Okay, where are we greater than 0? All right, that's right. It looks like we're greater than 0 on the tails again. Notice I did not do test points. I do my plus minus scheme. It goes faster. Because if you did a test, if you did a test points, you'd be doing a lot more work to see when this thing is positive and negative. And we've talked about that. Okay. And right now I know we've only had 3 regions, but you are going to see problems where you're going to have multiple regions, not just 3. You'll have 4 and 5 regions. All right, so let's do our number. Let's do our solution. That's right. So negative infinity to negative 2, union negative 1 to infinity. Okay. Last but not least, problem number 5. Okay. That's right, you're going to make it to 0. Minus 2, I'm going to give myself a little space here, less than or equal to 0. All right, we have to combine fractions, so I need to have, multiply top and bottom by an x plus 4. So I have we have what? 1x, just an x plus 4 in the denominator. I have an x squared. Now remember, you're distributing a negative 2. So negative 2x minus 8 less than or equal to 0. Uh-oh. Looks like we have to do some real factoring. That's right, that's 2 parentheses. X and x minus 4 plus 2 all over x plus 4 less than or equal to 0. So, what are the zeros here? That's right, we have a 0 at a positive 4, we have a 0 at a negative 2, and we have a 0 at a negative 4. Okay? Put them on the number line in the proper order. If you don't do the proper order, you're just going to get the problem wrong. So negative 4 goes first, then negative 2, then positive 4. All right. Now fill in your, so negative 4, that's right, that's an open circle. All right, plus 4s and negative 2, the numerators are the closed because the inequality. Remember, negative 4 is your denominator, that's always open, that's your undefined. So these are closed. All right, I'm just going to start writing them down. It doesn't matter what order you put them in, just start writing them down, your factors. So here's my x plus 4, my x minus 4, my x plus 2. Oh, I should have given myself a little bit more room there. All right, so now notice we have a lot of regions here, 1, 2, 3, 4. So again, if you wanted to do test points, you'd have 1, 2, 3, 4 of them to do. Okay, why would you want to do all that work? Just do your plus minus schemes. All right, so negative 4. Here's negative 4. To the left, it's negative. To the right, positive. Negative 4, x minus 4. So there's plus 4 right there. To the left, it's negative. To the right, positive. Then the last one, x plus 2. There's the negative 2. Left, negative. Right, positive. And we're looking for what? That's right, less than 0. Where are these things less than 0? That's right, 3 negatives is less than 0. Negative, negative is positive. This one's less than 0. All right. And we have our nice easy peasy solution set. And we have what? So negative infinity to negative 4 parentheses, union, oh, look at that, negative 2 comma 4 in brackets. Okay. All right, folks, that's your video for rational inequalities, solving rational inequalities.